Jai Hind, I am Dinanath Prasad. Today I am going to discuss on the topic of variable frequency drive. As we know, there are various companies having a different module of variable frequency drive. So in this lecture, basically I have discussed the basics of Sinamics G120 variable frequency drive, that is AC drive, that is made of Siemens companies. There is companies coming different frequency variable frequency drive. So basically I am focused on Sinamics based G120 VFD. So these are the content of my lecture. First of all, I will discuss about the introduction about drive, means what do you understand by drive, what is drive, how the working of electric drive. Now then I will discuss the basic block diagram architecture of VFD circuit, what are their schematic diagram of VFD circuit, how we control inverter control circuit we used in a VFD circuit. Then I will cover PWM technique. This is PWM technique is necessary for the inverter control circuit. So in this lecture I will cover how to PWM signal generation signal will be generated, and what are their important parameter in PWM technique, what are their different types of pulse width modulations, and next I will cover here. Basically I have covered the VFD device. That VFD device is used for the induction motor starting. So I will give you some small introductions about the different types of induction motor starting methods, and what are their industry used. Basically used, they are using soft starter and VFD device. So I will cover here what are their major difference between the soft starter and the VFD devices, and then I will cover what are their advantages, applications of VFD devices, and for that just small introductions about the Sinamics G120 drives. I will discuss about what are their important features about the Sinamics G120 drives, what are their units, what are their features. These all points I have covered in today in lecture. So first of all, come to the start of the topic, electrical drive. What is electrical divide? What do you understand by electrical drive? So electrical drive is a system which control the motions of induction motor or motions of the electrical machine or motor, that is known as electric drive. So you can see if we go to brief classifications about the drive. So basically two types of electrical drives are used. One is AC drive and another one is the DC drive. So this diagram shows the Sinamics based, that is the Siemens based AC drive, and this is the drive unit of DC drive. Come to what is VFD. So we know that the VFD is known as variable frequency drive. There is a various other names are there also there, like we can know the in common name, mostly we call variable frequency drive, that is a VFD. Another one is said this is AFD, that is adjustable frequency drive. Someone say this is VVVF drive, that is known as variable voltage variable frequency drive. So all the functions have means we vary the frequency, we controlling the frequency, supply frequency, we can control the motion of the induction motor or motion of the induction machine. So by varying the frequency, we control the speed or speed of the rotor. That's why their name is variable frequency drive or adjustable frequency drive. Or by varying the frequency, we can control the voltage itself. So that's why their name is VVVF, that is variable voltage variable frequency drive. So what are the major difference? Basically VFD device or AFD device or VVVF device are used for the industrial purpose, the industrial purpose of motor or controlling of their motor. So other industrial application like a soft starter, they can be used for the smooth starting at the time of starting and smooth controlling or stopping of the motor. But in the special feature of about VFD or VVF drive is that it can be control the speed of the motor during the start time or during the stop cycle or a stop time, and as well as throughout the complete run of the cycle. So we can control, overall control can be controlled smoothly and in a various wide range we can use as a VFD device. So this is the circuit diagram of VFD circuit, that is of Sinamics circuit. So now coming out the working of the device, working of VFD, how VFD is working. So basically the main function is to regulate the speed, regulate the motions of the induction motor. So by the controlling of the supply frequency, we can controlling the voltage. We know the in general formula, that is NS, that is the speed, or it is called as synchronous speed formula. We know, we generally use, that is 120 F upon P, where F is the supply frequency and P will be the number of the pole of the circuit. So if we vary the frequency, like if we put the frequency F is 50, F is 50, that is the supply frequency of our country India. So in that case, if we suppose number of pole is 4, that is the number of pole, 4 pole machine, pole induction motor, on that case we will find the synchronous speed is 120 F upon P, that is of 1500 RPM. This is the synchronous speed. So if we measure the what is the rotor speed of induction machine, that can be measured through the tacho generator. That speed will be measured around 1455 RPM, that is the speed of the rotor. That we know the induction motor is always less than the synchronous speed, that's why their name is asynchronous machine or the induction machine. Through that we can calculate the slip. Slip will be calculated, we know that NS minus NR upon NS. So that we can calculate the slip also or percentage slip also. But we in this point we I am not focusing about the slip, only I am focusing about the what will be the variations in the speed. So there is the variations of speed, that is of 1500 for with this condition. But we can analyze what about the voltage by varying the frequency. You can see the in a 50 hertz the voltage will be around 400 volt. But if we reduce the voltage, let's suppose for the 40 hertz, means we can reduce the frequency of by 20%, their synchronous speed will also reduce by this formula of 1200 RPM. That means their synchronous speed will also reduce to 20%, as well as the rotor speed is reduced also around 20%, that is not exactly 1100 to 64, that will be varied, but there around voltage will be 20%, then voltage will also reduce to this amount, that is of 320 volt. If we reduce half of them of 50 hertz, that is of 25 hertz, that is 50% of 50 hertz, the speed will be reduced to 750 RPM. That means 50% of the synchronous speed will reduce. Similarly, their rotor speed will also reduce, their voltage will be also reduced. So their name is VVVFD, that is variable voltage, variable frequency drive. There is another name. So, in all case there is a supply, this is the supply voltage Vs of, this is for 3 phase, we can take at for single phase also. Their frequency can be varied, the supply frequency can varied for the one cycle, as supply frequency is fed to this and motor, fed to the motor, their rotor speed, that is rotational speed, can also be controlled, also can be varied. That is the necessary conditions for any industrial purpose or industrial use. We can vary the speed as per our requirement. So, that can be varied with this VFD devices. Okay. So, now come to schematic diagram of VFD device. So, you can see this diagram, this is the block or you can say unit of the VFD devices. In that case we can supply frequency as either 50 hertz or 60 hertz or any frequency power that can be varied according to our requirement. That will that supply will varied, or AC supply can be varied to the motor. But how it the varied, what are their internal circuitry inside this VFD devices is this. So, first of all the supply frequency will be fed to the rectifier unit. This is made up of diode, or they can be used as a controlled SCR that can vary from conversion will be done from AC to DC. So, we will get here the DC voltage of this nature, means you can find the DC voltage of fluctuating in nature, not a constant DC. We required we can put here a capacitor. So, what are the function of capacitor here? The function of capacitor here is to vary this voltage, that is the fluctuating DC voltage, it convert it into the constant DC. So, this constant DC is further fed to the inverter circuit. Then what is the function of inverter? Everyone knows the function of inverter is directly convert from DC circuit to AC circuit. And what are the AC? They are directly convert from DC to AC. But what are the requirement? This AC power, it fit to the load, or it fit to the any induction motor for rotating of the machine. So, how to adjust, what are our requirement, how to change the speed, that I will discuss on the next slide. So, this I have covered, like we feed 3-phase AC supply to the circuit. This is the rectifier. Rectifier is nothing do, this is conversion from AC to DC conversion, and this circuit is the DC bus. This is DC bus, or it is work as a filter to convert into the constant DC supply. And this is the main important part, how to DC bus constant will be done, how to DC bus will be regulated, and that this DC bus is fed DC supply through this DC bus, DC supply is fed to the inverter circuit. So, the controlling of this inverter circuit is very important for controlling of motor, or adjust the speed of the motor or any supply, any load will be connected through it. Or you can see here the circuit, we cannot feed directly AC supplied to the rectifier. Here this is connected through this red line is connected through this, and I will find yellow is connected through this, and another one is blue one is connected through this. So this is connected with the supply, this is not individually connected. So what are the function of this? So there is a two type of circuit breaker is there, you can find here, that is RCCB and ELCB. Everyone know what is ELCB? ELCB is known as earth leakage circuit breaker, and this is another circuit breaker, that is RCCB. The function of ELCB, this is both are same, that is either we use ELCB or RCCB, the to any malfunction, any fault in the circuit from the source side, or in case of load side, they can directly trip the circuit and protect the circuit. That's why this circuit breaker is necessary. And there is a reactor. What is the function of reactor here? Basically, the one of the disadvantages of VFD circuit is that in case of using VFD circuit, there is a chances of harmonics will be generated in the circuit, or due to the switching of this rectifier and due to the switching of this inverter, the harmonics may be generated in the circuit. So through the reactor, that harmonics can be minimized and that can be rectifier. That's why we will put as a rectifier. And there is this is not reactor, this is basically, this is contactor. That what is the function of contactor? If there is any fault, or for the operating of the complete circuit, this is work like a relay, but their range will be higher than the normal relay, just to sensing the signal to the circuit. And this can be also controlling through the PLCs and all. So this is the important part of the circuit, that is the control unit, how to control and how to control this inverter circuit. So now come to inverter controls unit. So I will cover here inverter controls circuit, only discuss this part. Other part I have discussed previously, that is the rectifier. Why we use rectifier? That is the conversion from AC to DC. The DC bus, that is the fixed DC to the supply and to reducing the harmonic. Now to inverter circuit, we know we supply as a AC supply, whatever with the frequency, as a 40 Hertz, 50 Hertz, 60 Hertz, according to their supply frequency, we convert into DC. But the inverter, there is a, let's suppose this is this is not suppose this is 3-leg inverter, and this is mainly based upon IGBT. Why we use IGBT? We knows that this is power electronics based devices. We can use normal any semiconductor switches, or we can use as a MOSFET, we can use as a IGBT, but mostly we use IGBT. What is the function of IGBT? Because their switching frequency is very high as comparisons to other semiconductor devices. Means this is acts like a switch. This is act like a switch. So if we operate the circuit, if we control the motor, how fast this switching will be done. That means how fast they will be on, how fast they will be off. That controlling of on off will be done through this power electronics devices, that is IGBT. So through this IGBT basically pulses. This is sinusoidal. signal, there is, you can find there is a pulse. This pulse width and pulse magnitude for the one cycle we can control. For the one cycle means how we control this breadth, how we control this magnitude, that can all be controlled with the help of switching devices or signals. So this I have discussed on a further slide. We use a PWM technique. PWM we all knows is a very general, very most used common used controlling of output of any inverter circuit. This through this we can control the width of the gating pulse. This can be controlled with the width of the gating pulse of any inverter circuit. This gating pulse we generated by comparing, we compare two signal. That signal is known as either the reference signal or other signal we called as carrier signal. So how to control, what are their technique, that I have covered in the next lecture, but we can see in this diagram, this is modulating signal, or it is known modulating signal, or it is known as reference signal, and other one is carrier signal. That both are compared, and after comparing we will get this pulse. So we will getting this pulse by comparing these two references signal of this. We will switch the inverter circuit. You can see the duty cycle. What is the duty cycle? I will discuss in a next lecture. So what is the you can see in this circuit there is a 50% duty cycle, there is a 75% duty cycle, there is a 25 duty cycle. We can control the width of the on-off cycle of the inverter. So we can basically control the on and off of one time period. With this, on and off is called one time period, and through that we can control the pulse width. How we control, that I have discussed in the next slide. So for the PWM generation technique, we use a comparator, a device that is used a comparator. We can very easily generate either in a hardware module or in a software module. We compare two signal, one is a sinusoidal signal, other one is non-sinusoidal signal. So non-sinusoidal signal we generally use a sawtooth waveform. So after comparing this modulating signal or reference signal with the carrier signal, we fed to the comparator. Accordingly, the pulse will be gating pulse will be generated, and this gating pulse we use to the inverter circuit for controlling the inverter. So what are the important parameters used in a PWM technique, which is known as duty cycle? What is duty cycle? Duty cycle is nothing but the T on time divided by T on time plus T off time. So you can see in this diagram, for this pulse, this is the on time, this is off time. So this is total time, that is on time or off time, that is one called one period, that is the T on time plus T off time. If we calculate the percentage of duty cycle, we calculate as T on upon T on plus T off. If we multiply by 100, it is known as percentage of duty cycle. This is important point to know what are the duty cycle of this pulse or the supply. Another one important to know what is frequency. So frequency is anything that is of 50 hertz or 60 hertz or any frequency, or we knows that what is the relations with the time period, that is frequency is 1 upon time period. So As discussed, this is the on time, this is the off time. The total on time plus off time, it is known as time period. A duty cycle is T on upon T on plus T off. So let's suppose just for an example, we calculate how to calculate the on time or off time of a circuit. Let the supply frequency of 50 hertz. So if we supply frequency of 50 hertz means the time period will 1 by 50, that is of 0.02 second. That means there is a 20 millisecond. So we will calculate the total time period, that is total time period is, this is total time period, or you can see in this diagram 20, that is T on or T off, that is 20 millisecond or 0.02 second. So here we take as a duty cycle for the circuit is 60%, means this is percentage of duty cycle, percentage of duty cycle is 60%, that is of 0.06, just we put a duty cycle as 0.6, that is T on plus T on plus T off. We calculate T on plus T off, that is the time period of 20 millisecond. Through that we can calculate the T on time is 0.6 into 20, that is of 20 millisecond. So this circuit is on, the circuit is on for this 12 millisecond. So if we know the total time period, that is of 20 millisecond, on time is 20 millisecond, so we can calculate the off time period is just 8 millisecond. So for any duty cycle we can calculate, if we know any duty cycle, what should we put the duty cycle, we can know the T on time and T off time, as well as the amplitude of the signal is also controlled, that is necessary to controlling the voltage, that can be controlled through the SCR. Now come to types of pulse width modulations. Up to that we have discussed what is pulse width modulation, but there is a different types of pulse width modulation that I have covered in this here. Going to cover, that is the single pulse cycle, single pulse technique. What is single pulse technique? In this case you can see for one time period, that is on plus off, for this on there will be one carrier, and there is a one reference, that is square wave, and for the off cycle there will be one reference signal will be a squared wave, that is of half of that, and carrier signal of this. So how the pulse will be generated? So you can see the carrier signal is high. In this case there will be no pulses will be generated from the with respect to reference signal, but as the carrier signal is less than the reference signal, as it is less, then there will be a pulse will be generated. From which durations they will generated? The generated for when the reference signal carrier signal is less than the reference signal, as the reference signal is higher than the carrier signal will be higher than the reference signal, then again we will get the off. Again from this case, as the carrier signal will be less, then pulse will be generated. If the carrier signal will be high, the pulse will be not generated. Accordingly the pulse will be generated, and accordingly the voltage will be generated, and voltage magnitude will be generated. So this is the single pulse technique. So in this case only one rectangular reference signal and one carrier triangular signal will be used. Now next type of pulse width modulation, that is multiple pulse technique. single pulse technique only one rectangular signal and one triangular signal or one sawtooth wave signal will be there, but in case of multiple pulse technique, here only one sorry, here is only one pulse, but there is a various sawtooth wave you can find here, that will be used according to application to application. So in this case again the same principle we use for the generations of switching pulse. You can say this is the switching pulse, as same as the reference carrier signal is less than the reference signal, the pulse will be generated. If the carrier signal is more than the reference signal, pulse will be not generated, that means off. So for this duration the circuit will be turned on, means switch will be on, we can switch on to the IGBT, and for the other case that cannot be used, means there will be turn off the circuit. Similar other last, that is sinusoidal PWM technique. In same sinusoidal signal PWM technique, the reference signal will be a sinusoidal wave, and the carrier signal will be same as a triangular wave or sawtooth wave. So same way we can generate here, as the reference carrier signal is less, then the pulse will be generated. If the carrier signal is more, then pulse will be not generated. So there is a three ways we can generate the pulse width to the circuit. Now come to important block diagram of VFD circuit. This is important for controlling of any motor, induction motor or any process in our industries. So first of all, let's start from here. You can see this is line L1, L2, L3 is the supply voltage. They can be 3 phase, they can be single phase. For the 3 phase there will be 3 supply. For the single phase there is a 1 phase, another one is neutral, that will be fed to the diode rectifier, that convert AC into DC. There is a filter circuit, that is a capacitor, or mostly the capacitor is used as a electrolyte type of capacitor, that convert the fixed DC into the inverter, that will be convert AC into DC into AC, but they are not directly fit to the AC motor, that directly not fit to the induction motor. So other thing is to be noticed here, is here there is a dot here written analog input, digital input, HMI, VOP, AOP, PLC. There is a different kinds of input for the taking the speed reference control. So either we can put according to our requirement, according to our use, what source will be available, we put as a analog input. Either we take analog input, either we take digital input, either we take input from HMI, that is human machine interface, that is VOP is known as basic operating unit, that is AOP, that is advanced operating unit, or we can take data from the PLC. That can anything we can use to give the speed reference control signal to the circuit. Now it come to ramp control. So any of the motor, either we use basic control or advanced control and a ramp control just to start the motor. Like the circuit is like this in a basic ramp, and a stop will be this. So this is the on time, this ramp will be used. This is the off time ramp will be used, or either we ramp will be used as like this, like the rounding shape. So this is used generally smooth applications, that can be ramp control or ramp circuit will be used according to the use, how the smooth work, how the precise work we are going to done. Now come to, there is a some controller we use, that is sometimes we use PID controller or PI regulator. In Schematic G120 drive there is a PID block. Through PID controller we can control the circuit, but for the simulation purpose we can use AI technique, that is artificial intelligence technique. We can use fuzzy logic instead of PID controller. We can use NN technique, we can use NFS technique for the regulations, and after that we can control, we can measure this controller or regulator with the actual speed. That actual speed is getting through the either digital input or either analog input that can be get from the encoder or through the tachometer, that through that compare the error signal will be generated here. That error signal is again fed to the torque reference controls. For the torque reference control we will get through sensor. Basically there is a relay. That relay is feed current feedback signal, and there is a torque will be compared. Accordingly the torque will be compared, and this reference signal is fed to the inverter cycle through the PWM technique. So through that the operations will be done. So now basically I have discussed here the controlling a starting method of induction motor. So you can see these 4 or 5 are the basic, or you can say conventional method of 3-phase induction motor starting, that is DOL starting, that is known as direct online starting. A starter resistance method, there is also we use as a rotor resistance method. Rotor resistance method, we can use auto transformer starter, we can use a star delta starter. In all cases, all 5 cases, direct online starter resistance, starter resistance, rotor resistance, auto transformer, star delta starter, the input current, the initial current when the motor will be a start, they draws very high amount of current. That will depend upon the applications to applications. So what are the disadvantages of drawing high or large amount of current? This current may harm to the induction motor. Their life will be reduced, there will be large effect on the induction motor. So we that cannot be used in a various industrial purpose. We need to induction motor to be a start in very safely in the industries. So direct online starter, in case we directly connected to the supply, as they are there is initially very large amount of current will be drawn. So this is absolute method. We cannot use a starter resistance method or rotor resistance method. Some resistances are connected in a series fashions. We can close the switch like in this sequence. As the motor runs on a rated speed, then we disconnect the switches so that initially the voltage drop will be reduced. Then in case of auto transformer, we use for the starting of an induction motor, we use auto transformer. With the help of auto transformer, voltage will be controlled. As the induction motor come on the running condition of 70% around, then they will be cut out from the circuit, and we can reduce the large amount of current. Same in case of a star delta starter, initially they are using in motor will be a start on a start condition. On that case, voltage will be V upon root 3, the voltage will be reduced, current will be reduced, and then after the motor will be a start, that the switch will be converted into the delta fashion. So this is old, or you can say conventional technique, not used in a very various industry purpose. So this is the starter method. So this starter basically used in industry or VFD will use. You can see as I discussed earlier, software starter used for motor start and a stop, but VFD can be used a start and a speed control, that is throughout the operations. So a software starter will be bypassed after motor reaches to the full speed, but the VFD control, that can be circuit you can find. This is the SCR. The switches when come into the full speed, they will be bypassed through this bypass contactor, and the motor will be controlled. But this is only used for the start and a stop of the motor, but VFD control the throughout the operation. If we required smoothly operations will be required, we use VFD device. It injects the harmonic. This is it does not eject the harmonic in case of software starter. This is a starter. This is the major advantages you are using software starter. But in case of VFD, we use the harmonics. That's why we need filters here. So that's why this is less expensive, this is more expensive. Space requirement is less. This is largest special required. This is energy save is less in this case. This is more energy saves. But if we talk about industrial purpose, mostly we use VFD devices. So these are the advantages. We can use the for power factor improvement, as in case of DC motor reactive current is supplied by the DC bus. That's why power factor is improved. We can use for controlling a starting or stopping of accelerations, or throughout the operations we can use as a VFD device. We can use as a energy saving. We can use for higher starting torque. We can use as a protection, any kind of protection like short circuit, overcurrent, earth leakage. We can use as a protective devices. We can easily reversible of the motor. We can use VFD. So these are the applications. We can use in a conveyor system where the speed variations, the precise speed requirement, where is a different of motor is connected. So we can use here conveyor system. Various machine and tool industry, we use VFD devices. In a lift and accelerators, we use VFD devices. We use VFD as an application in railway. In case of DMRC, we use VFD devices. So about Sinamics devices, so we can know Sinamics G120 is a very universal variable speed drive. This is full range industry requirement machinery used in masonry construction. We can use in textile, printing, automatic, and chemical industry, many more places we use Sinamics G120 Siemens based drive. The range of applications will be very high Sinamics G120 drive comparing to the other drives. Their applications components will be very wide, which is used to configure very easily way, and their communications is very easy as comparisons to other drive system. There is some features of Sinamics G120. There is a wide range of applications, like from very small range from 1.12 kilowatt to 120 megawatt. This is available for low voltage and medium voltage versions. We can use a standard and refined functionality as a common hardware and software platform. They can these all drives are energized exactly in the same beam, like we use sizer for engineering. We can use a starter for parameterizing and commissioning. They are having various high flexibility comparing to other drives. Their parts can be easily selected and replaced. Their cost will be not much higher than comparing to other device. So these are the drive unit. Not in this lecture. In the coming lecture, I will discuss more detail on about the power this drive unit. So basically there is a three unit: power unit, control unit, and operating panel. They are coming in this shape. This is on compact packs. This is, you can see, this is the operating panels. We can control from here. We cannot go to the software through that operating panel. We complete control of the, either we controlling the speed, we can control the motions, or any software regarding we can control through this operating unit. This is control unit. Basically for the communications purpose we use Profibus, Profinet circuit, communications with the devices system we can control through this control unit. We will discuss on the next lecture on detail. This is the power unit, all the conversion which I have discussed in the lecture, this is coming here, all electronic circuit, switching circuit, all parts are in a power unit. So this lecture detail about Sinamics G120 drive I will discuss on the next lecture. So thank you for that, thanks for the patience listening. You can find me on this web ID or through this. Thank you.